Good day, everyone. I am Micaela Pereño, 11 STEM 28, and I am here today to discuss about the basic rules of limit through video presentation. As I've said, our topic for today is the basic rules of limit. I know at this moment a lot of things comes into your mind the moment you hear the word limit. But before we dig deeper to our objective for today, let us know first the limit itself or its definition.
What is limit? A limit is defined as a value that a function approaches the output for the given input values. Limits are important in calculus and mathematical analysis and used to define integrals, derivatives, and continuity. Also, a limit is an idea wherein a basis of all calculus. A limit tells us the value that a function approaches as the function's inputs gets closer and closer to some number. So now we have already know the definition of a limit. Let's begin. For our theorem number 1, the constant of function. Constant of function for limits states that whatever the value of where the x approaches or the value of a, what the constant or the value of c is always the answer. The limit of a constant function c is equal to the constant. We read it as the limit of c as x approaches a is equal to c, where c is a constant. So to illustrate, let's have our example. For our example, we have the limit of 16 as x approaches 16 is equal to 16. The constant here, or the letter c, is 16, so we are just going to copy 16 and the answer is simply 16. Next, for our second example, we have the limit of negative 6 as x approaches 7. That would be negative 6 because the constant here is negative 6. We are just going to copy the negative 6 and then the answer is negative 6. So that is the constant of function, the theorem number 1. So let's proceed to the theorem number 2, the limit of x. The limit of x states that the answer is always where the x approaches or the value of a. For any number a, the limit of a as x approaches a is equal to a. So it is just almost the same on the previous theorem, the theorem number 1, but the difference is we are not going to copy the constant, and the constant is not the answer because the answer is the value of where the x approaches. So to illustrate, let's have our example. For our example number 1, applying the rule or the theorem number 2, we have the limit of x as x approaches 16. So the answer is 16 because the value of where approaches is 16. Next, we have the limit of x as x approaches 1/2 is equal to 1/2 because the value of where the x approaches is 1/2. So we are going to copy the 1/2 and then the answer is simply 1/2. So that is the limit of x, the theorem number 2. Next, we are going to proceed to the theorem number 3, the limit of a constant multiple rule. The limit of a constant multiple rule k multiplied by a function equals the constant multiplied by the limit of the function. Suppose that the limit of the function x as the x approaches a is equal to L, then the limit of the quantity k times the function x as x approaches a is equal to the constant times L, where the k is a constant. The k here is the constant. So to illustrate and to understand, let's have our example. So for our example, to apply the theorem number 3, we have this example, the limit of 7x as x approaches 3. So we are going to just copy the constant 7 and then write what is left, the limit of x as x approaches 3. Now we are going to bring down 7, then we apply here the theorem number 2, so we are going to copy the value of here the x approaches, which is 3. Now we are going to simplify. 7 times 3 is equal to 21. Now for our example number 2, we have the limit of 7x as x approaches to 1/2. So we are just going to copy the constant 7, then we are going to write what is left, the limit of x as x approaches to 1/2. Then we are going to bring down the 7, then apply the rule number 2. We are going to get the value of here the x approaches, which is 1/2, then simplify. 7 times 1/2 is equal to 7 over 2. So that is the limit of a constant multiple rule, theorem number 3. So let's proceed to our theorem number 4, sum and difference rule. The sum and difference rule states that a sum or a difference is integrated termwise. Again, suppose the limit of f of x as x approaches a is equal to L, and the limit of g of x as x approaches a is equal to m. Then the limit of quantity f of x plus minus g of x is equal to L plus m. To illustrate, let's have our example. This part, I am going to discuss first the sum example, and then next we are going to have the difference example. So for the example number 1, we have the limit of 3x plus 5 as x approaches 1. That would be the limit of 3x as x approaches 1. Here in this part, we are going to apply the theorem number 3. So we are just going to get the constant and then write what is left, the limit of x as x approaches 1. Then here we are going to apply theorem number 1. So we are going to copy the constant, which is 5. Next, we are going to simplify. So 3, bring down 3. Then in this part, we are going to apply the theorem number 2. In this part, we are going to apply the theorem number 2. So we are going to get the value of where the x approaches, which is 1. So we are going to bring down 1. Then bring down also the number 5. So 3 times 1 is equal to 3 plus 5 is equal to 8. So the answer is 8. Now let's have the difference one. So we have the limit of 2x minus 6 as x approaches negative 3. That would be the limit of 2x as x approaches negative 3 minus the limit of 6 as x approaches negative 3. What we did in the first one is what we are going to do in this second example. So we just separated the 2x and negative 6. And then we are going to distribute the limit of as x approaches negative 3 on each. So now we are going to apply the theorem number 3, bring down the constant, then write what is left, the limit of x as x approaches negative 3. Then apply the theorem number 1, copy the constant 6, so that would be 2 times the limit of x as x approaches negative 3 minus 6. Now we are going to bring down the 2. Then in this part we are going to apply the theorem number 2. We are just going to copy the value of where the x approaches, which is negative 3. Now we bring down also the negative 6. 2 times negative 3 is negative 6 minus 6. So that would be negative 12. So that is theorem number 4, sum and difference rule. Let's have the theorem number 5, product rule. Product rule, multiplication is equal to the product of the limits. In other words, find the limits of the individual parts and then multiply those together. So again, suppose that the limit of f of x as x approaches a is equal to L, and the limit of g of x as x approaches a is equal to m. Then the limit of f of x times g of x as x approaches a is equal to L times m. To illustrate, let's have our example. For our example, we have the limit of x, quantity 3x plus 1 as x approaches 2. So, applying the theorem number 5, that would be the limit of x as x approaches 2 times limit of 3x plus 1 as x approaches 2. In this part, we are going to apply the theorem number 2, so we are going to get the value of where the x approaches, and that would be 2. Next, in this part, we are going to apply the theorem number 3, so we are going to get the constant 3 and then write what is left. The limit of x is x approaches 2. Then the 1 will be the limit of 1 as x approaches 2. Then we are going to simplify. We are going to bring down 2, bring down the 3, and then in this part we are going to apply the theorem number 2. So we are going to get the value of where the x approaches, which is 2, and in this part we are going to apply the theorem number 1, so we are going to get the constant is 1. Then bring down 2, simplify. 3 times 2 is 6 plus 1, so 6 plus 1 is 7, and 2, bring down 2 times 7 is 14. The answer is 14. So that is for the product rule, the theorem number 5. Now let us level up to the theorem number 6, quotient rule. Quotient rule for limits states that the limit of a quotient of functions equals the quotient of the limit of each function. Again, suppose the limit of f of x as x approaches a is equal to L, and the limit of g of x as x approaches a is equal to m. Then the limit of f of x over g of x as x approaches a is equal to L over m, wherein m must not be equal to 0. To illustrate, let's have our example. So we have here the limit of x over 2 as x approaches 5. So applying the theorem number 6, quotient rule, that would be the limit of x as x approaches 5 over the limit of 2 as x approaches 5. In this part, we are going to apply that theorem number 2, so we are going to get the value of where the x approaches, which is 5. And in this part, we are going to apply the theorem number 1, so we are going to get the constant. The constant is 2, so the answer is 5 over 2. Simple as that. So that is the quotient rule theorem number 6. So let's have the theorem number 7, the power rule. Power rule states that the limit of the power of a function is the power of the limit of the function where p is any real number. The limit of f of x raised to p as x approaches a, that is equal to the limit of f of x as x approaches a raised to the power or the exponent. That's how we read this. To illustrate, let's have our example.
For the example, we have the limit of x raised to 3 as x approaches 2. Applying the rule of power rule or the theorem number 7, that would be the limit of x as x approaches 2 quantity to the power of 3. So basically, we just put quantity on the problem and then we put the power on the outside of the quantity. So now we are just going to apply the theorem number 2. So we are going to get where the value of x approaches, that is 2. And we are going to copy the power or the 3. So 2 times 2 times 2 is equal to 8. For our second example, we have the limit of x as x approaches 2 raised to 2. Applying the theorem number 7, that would be the limit of x as x approaches 2 raised to 2. We apply the theorem number 2, so we are going to get the value of where the x approaches. So we are going to copy the 2, and also we are going to copy the power, which is 2. 2 times 2 times 2 or 2 squared is equal to 4. So that is the theorem number 7 or the power rule. Now let's have the last one, the theorem number 8, the radical or root rule. Radical or root rule for limits states that the limit of the nth root of a function equals to the nth root of the limit of the function. We read this as the limit of square root of x as x approaches a, that is equal to the square root of the limit of x as x approaches a.
To illustrate, let's have our example.
For our example, we have the limit of the square root of x as x approaches 9. Applying the theorem number 8, the radical rule, that would be the square root of the limit of x as x approaches 9. So in this part, we are going to apply the theorem number 2. So we are going to get where the x approaches, which is 9. So we are going to bring down 9, and we are going to bring down the square root symbol also. So the square root of 9 is 3. For the second example, we have the limit of the square root of x as x approaches 12. Applying the theorem number 8, that would be the square root of the limit of x as x approaches 12. And then apply the theorem number 2, we get the value of where the x approaches, which is 12. And then we are going to bring down the square root symbol. 12 is not a perfect square, so the
answer would be 2 square root of 3 or 3.46, or when rounded off 3.5. That is the radical rule or root rule, theorem number 8. To summarize, these are the basic rules of limit theorems. Number 1, constant of function. Next, we have the limit of x and constant multiple rule. Next, we have the sum and difference rule to be followed by the product rule, and also quotient rule and power rule, and last but not the least, radical or root rule. Do you have any follow-up questions for me? Well, I guess none.
Again, this is Micaela Pareño from 11 STEM 28. Thank you for your time and appreciation. That would be all, and thank you for watching.